Okay, guys, here is section 6.2, day 2. After 6.2, day 1 notes, and seeing how we apply trig to an angle that meets a circle, and how we redefine the trig ratios using x coordinates, y coordinates, and a circle's radius, we should now be fully aware as to what the unit circle is showing us. The unit circle is showing us that any angle that intersects the circle has an x coordinate that is equal to the cosine of that angle. Any angle that intersects the circle has a y-coordinate that is equal to the sine of that angle. That's it. That's the only thing the unit circle is showing us. It's showing us that it's showing us what the sines and cosines are of all of these special angles. All of these multiples of 30s, 60s, 45s, all of them now, you now know what their cosines and sines are using the ordered pairs that are on this circle. Also, by using trig this way, with an angle and a circle, it allows us to find trig ratios for angles of any size, big, small, positive, or negative. I can now find the sine or cosine of an angle of any sine. So because of this, you are expected to memorize your special trig ratios of all of these special angles. So if someone was to ask you, oh, what's the sine of 240 degrees, you would go to where an angle that is 240 degrees big, where it intersects the circle, its y-coordinate is representing the sine of that angle. So the sine of 240 degrees is the ratio -√3/2. If somebody asked you, oh, what's the cosine of 135 degrees? You would go to where a 135 degree angle intersects the circle, and its x-coordinate is telling you what the cosine of that angle is. The cosine of 135 degrees is -√2/2. Okay, but that's the problem I have with the unit circle, is that in order to use it, in order to know what all of these special trig ratios are of all of these special angles, you have to either have one handy or you have to be able to draw one from scratch. Now, drawing one from scratch is not that hard. It just takes time. And if you want to see how the unit circle physically gets constructed, you can YouTube that just to try and save you time. I'm not going to put that in the video. So I find myself not using the unit circle all that much just because of having to draw it every time. So I'll show you how to do that if you don't want to draw one every single time. But if you're not going to use the unit circle, then you need to remember certain things. You need to remember your special right triangle side lengths. Your special right triangle side lengths. And all students take calculus, that thing that I showed you at the end of the day 1 notes. All right, so just to review that really quick. All right, remember, if you can remember these special side length relationships on a 30, 60, 90 and a 45, 45, 90, and if you remember what we've done is we've taken all these angles that now are going to intersect a circle, we're using their x and y coordinates to represent their cosines and sines, right? Because we have a radius of 1 on the unit circle, we can now have angles that fit inside of these right triangles who now have an x coordinate, a y coordinate, and when you start finding the sines and cosines and tangents of this angle, his cosine will be a over h, an x coordinate over a radius of 1, which is just x. So again, that x coordinate where that angle meets the circle is representing the cosine of that angle. If I find the sine of angle theta, O over h, that's y over 1. That's the y-coordinate. So the y-coordinate of that point where this angle meets the circle represents the sine of that angle. Now, the tangent is the only ratio that doesn't appear on the unit circle, but you can always build it by making it the y-coordinate over the x-coordinate. You could always take the y-coordinate from this ordered pair, put it over the x-coordinate, and that would be the tangent of that angle, okay? Well, again, because we're now allowed to apply this to angles of any size, you're going to have angles that land in quadrant 2. You're going to have angles that land in quadrant 3. You're going to have angles that land in quadrant 4. And you all know that as you move around the coordinate plane, angles or points that land in quadrant 2 have a negative x and a positive y. So you're now going to have angles that have negative cosine ratios, and you're going to have angles that have positive sine ratios. And then if you're an angle that landed in quadrant 3, you're going to pass through a point that has a negative x and a negative y. So now you're going to have a cosine that is a negative ratio. You're going to have a sine that is now a negative ratio. If you're an angle that landed in quadrant 4, then you're going to pass through a point that has a positive x coordinate and a negative y coordinate. So all the angles that land in quadrant 4 are going to have a positive cosine ratio and a negative sine ratio. So that's why we have the all students take calculus, to remind us what your ratio should be for an angle that lands in each quadrant. So we said that yesterday we have all students take calculus, right? Because if you're a ordered pair that landed in quadrant 1, then you have a positive x and a positive y. If you're an ordered pair in quadrant 2, then you have a negative x and a positive y. If you were an ordered pair in quadrant 3, you have a negative x and a negative y. If you were an ordered pair that landed in quadrant 4, then you have a positive x and a negative y. So the cosine of any angle that lands in quadrant 1 is going to have a positive ratio. The sine of any angle that lands in quadrant 1 is going to have a positive ratio. The tangent will be y over x. The tangent of any angle in quadrant 1 will have a positive ratio. All right? Any angle that lands in quadrant 2 is going to have a cosine that has a negative ratio and a sine that has a positive ratio. Any angle that lands in quadrant 3 is going to have a cosine ratio that is negative and a sine ratio that is negative. So the tangent, when you put the y coordinate over the x coordinate, is the only one who ends up with a positive ratio. And then any angle that lands in quadrant 4 is going to have a positive x and a negative y. So it's going to have a positive cosine ratio and a negative sine ratio. And then when you build the tangent of that angle by putting the y coordinate over the x coordinate, that tangent ratio for an angle in quadrant 4 is going to be negative. So only the cosine function gets you a positive ratio in quadrant 4. So if you can remember these and the all students take calculus, then you're going to be able to find the answers to the questions that you're asked without having to have a unit circle, okay? So really quick, if you are the unit circle, just to kind of keep putting this in your mind when we're going to need it, the unit circle being centered at 0, 0 with a radius of 1, don't forget that the equation of the unit circle is x squared plus y squared equals 1. All right? And then again, don't forget how these trig functions work. The 6 trig functions are functions of an angle. You plug an angle into all of them, and they spit out a side length ratio. So remember, angles go in and ratios come out. That's how these trig functions are going to work. So when you start being asked all these questions, you should at least understand what the answer to that question is supposed to be. So again, an angle or theta goes in. I think our book uses t though, because they use a real number t because it's going to be measured in radians. And then a ratio comes out. Okay. So what kind of problems are you going to be asked in this section? You're going to be asked questions like this: to find the exact value of the sine of a 300-degree angle. So you should know that when I plug an angle into the sine function, a ratio comes out. So the answer to this question has to be a side length ratio of O over H. Well, again, what the unit circle is for is they want you to be able to oh, you want the sine of 300 degrees? Well, then I'm going to go on my circle to where an angle that is 300 degrees big lands, and I know that the y coordinate represents his sine. So that means the sine of 300 degrees is negative root 3 over 2. But what if you don't have a circle? How do you answer that question without using your circle? It's not that hard, but there's a lot of values that I want you guys to be aware of. So I want to fill in, I remember doing this when I was in high school. I want to fill in this chart with you guys. If you have this chart, then all the answers are going to be on it, and you can start really kind of memorizing and recognizing what these ratios are without ever needing a unit circle. So I'm going to fill this chart in a separate video so you have it, and then I'll come back and do the actual examples to your 6-2 day 2 notes.